All right, so let's look at some of the stuff. So I'm going to go ahead and I've been experimenting with going full screen on this stuff lately. Interesting. So I'm going to right click and we're going to create a new class called fraction. Right? And fraction is going to have two private fields. Actually, big integer, right? Yeah. I don't want to have to spell denominator very often, so I'm just going to call it num and denom. And then we'll go ahead and import java.math to give us our big integer. So there's our two private fields. We'll create a public constructor. We'll have these guys take in a long num and a long denom. We'll probably end up making a couple of different constructors, but just for our starting point here, we'll have it take in two longs and create our big integers out of that. And we'll say num is equal to new big integer num. So this dot num is equal to new big integer. I need to go look at how did we create big integers last time? Make sure I'm doing it the way I showed you how to do it. Oh, string. Out of a string, okay. So empty string concatenated with whatever num is. And this dot denom is equal to new big integer empty string concatenated with denom. All right. So that will build our fraction. And let's see, what else am I supposed to do? Unit 3, homework 6. Fraction needs to be able to display itself. So let's go do that. So I'll create a public void display method. Display method will do system.out.println this dot num concatenated with a slash concatenated with this dot denom, and this will. Have we looked at the toString method yet in here? Okay. Well, we'll end up doing this today. It's fine. Because the reality is we're actually calling this dot num dot toString and this dot denom dot toString to make it work right. That'll make sense later, so it's not that important. So let's go ahead and test our early fraction here. So I'll come into, can't stand all this clutter. I'm just going to delete it. All right, so we're going to create a fraction. F is equal to a new fraction 1, 2. And we'll say f dot display. And hopefully we get 1/2 in front of the screen. Okay, so we're able to create fractions now. Let's see, what else we're supposed to be able to do. A fraction should be able to add itself to another fraction, returning a new fraction in reduced form. Okay, so go back into our fraction class. We're going to create public fraction add. This guy's going to take a fraction f as a parameter, and we're going to add two fractions together. Well, what does it mean to add two fractions together? Well, we need to get the common denominator, right? Greatest common denominator? Well, let's go ahead and just do the cross multiplication first. That's the way I like doing this. So let's do an unreduced form first. So what I'm going to say is I'm going to say big integer new num, big integer new denom. So we're going to have a new numerator and a new denominator we need to create. The new denominator is going to be equal to what? It's going to be equal to the two denominators multiplied together, right? So if I have 1/3 and I have 1/2, my denominator is going to be a 6. Okay? So this guy will be equal to a new, actually here we'll do it this way, will equal to this dot denom dot multiply f dot, now I need to be able to get my denominator, right? So that means I need to be able to create, I need to do source, generate getters and setters. And for right now, we'll just give ourselves both of them to make this easy. So I have all those guys now. So multiply by f dot get denominator. That makes sense? So that's my new denominator. What's my new numerator? My new numerator is taking this numerator times the other denominator and adding to that the other numerator times this is denominator. So new numerator is going to be equal to parenthesis this dot numerator dot multiply f dot get denominator, right? So that guy right there will give me the numerator times the other guy's denominator. And what do I want to do with that? I want to add that to what? I want to add that to the big integer that's returned by f dot get numerator, dot multiply this dot denominator. So this dot numerator multiplied by f dot denominator, that gives us a big integer. Then we'll add to that big integer f dot get numerator multiplied by this dot denominator, just like that. So that's my new numerator. So now I need to be able to build a fraction out of two big integers, right? Because I have my new numerator and I have my new denominator, so I need to create another constructor for fraction. Public fraction big integer num, big integer denom, and say this dot num is equal to num, this dot denom is equal to denom, and now I can create a fraction out of big integers. So I'll return a new fraction with new num, new denom for right now. This is not going to reduce it, but it gives me my starting point. That make sense? All right. So now I should be able to create two fractions. Fraction f2 is equal to new fraction, let's do 1/3. And then I should be able to say f dot add f2 dot display. So f dot add f2 is going to boil down to a fraction, right? Then I'm going to tell that fraction to display itself. So it should display 1/2 plus 1/3, giving me 5/6. Make sense? That's equivalent to me doing this. Fraction f3 is equal to f dot add f2 f3 dot display. So this one line accomplishes the same thing that these two lines accomplish, with the one exception that after this one line is done, I have no way of getting to my fraction that's 5/6. After these two lines are done, f3 holds my fraction 5/6. Make sense? So we'll see we get 5/6 twice here. But then similarly, I can say f3 dot display again, and we can see we can keep getting f3 over and over again, where I've lost the ability to get the original 5/6. All right. Questions about that? So now we need to be able to reduce this dude, right? So to reduce them, I need to go and get my greatest common divisor. Well, let's hit YouTube, hit the internet, GCD algorithm. I know we had this last time, but as you saw, I deleted it. Ooh, here's a recursive version of it.
GCD and under the big integer object. If you like big integer .gcd, there is another.
Oh, is there?
Yeah.
I didn't tell you how to use that.
Because it's written here. Because we did.
I did technically show you how to use the
multiple and divide and add.
the documentation for it. I'll allow it. I'd rather write it. Let's just write one of these. Although I am interested in the recursive version. That looks kind of fun, actually. So we'll come in here, and we're going to create a private function. Big integer, GCD, that's going to take a fraction f as well as this current fraction and give us the greatest common divisor. I'm going to paste this code in, even though we're going to. So in our code here, A is this, and B is f. So here we can even name this, no, screw it, just leave it as f. So while A and B are not, thought we had an emergency. We're good. I may or may not have hit the power button. Okay, while A and B are not equal to each other, which means that this dot, well, actually just this, dot equals, actually it's going to be interesting. How do I ask if two fractions are not equal to each other? See, greatest common denominator actually does not take in a fraction. It takes in a big integer b. We're going to actually write this better. It'll give us an opportunity to show something. I'm going to take in a big integer b and a big integer a. And we're going to make this guy static. We're going to make it static. I'm going to ask you why we made it static in a few minutes. It might potentially be a quiz, so keep that to yourself and think about it. So while a dot equals b, while that is not true, if a let's see, Yeah, it does. What, greater than? So really, you almost had to use the... Okay, well, this will be interesting. So, I want to say, well, A and B are not equal to each other, right? So while A dot subtract B dot equals well, that is not true. While it is not true that A minus B is equal to 0, the big integer 0. And if you didn't know about big integer 0 here, in fact, we're going to assume it because I don't want anybody having any dirt on me. I literally solved this using only tools you had.
Actually, you gave us that last time.
Hmm?
You gave us big integer dot 0.
Did I?
Mm-hmm.
Oh, all right. All right, so while A minus B is not equal to 0, that means they're not equal to each other, right? Mm-hmm. Okay. So while that's true, what am I going to do? I'm going to set A equal to A dot subtract B. Else, I'm going to set B equal to B dot subtract A. In the end, I'll return A. That make sense? So that is my GCD function for big integers. And then what I'll do is inside my add function, before I return, I'm going to create a big integer div. Let's call it gdiv. And we're going to call this guy I'm going to call my fractions greatest common divisor, passing at the numerator and the denominator, giving me gdiv. And I'm going to return a new fraction that is new num dot divide gdiv and new denom dot divide gdiv. That make sense? So I'll get my greatest common divisor by calling greatest common divisor on the numerator and denominator after I've done my math. And then I'll return a brand new fraction created by dividing the numerator by that divisor and dividing the denominator by that divisor. Make sense? Now, with our current set of fractions, I don't think we get any reduction. Did I click? Why do you hate me? isn't it running? Did we have this problem last time?
I forgot what the solution was then.
We could minus.
Hmm.
The A is smaller than B.
If A dot subtract B is not equal to 0, then set A equal to A subtract B.
So minus.
Otherwise, set B equal to B subtract A. Do that for as long as A and B are not equal.
Do we have to check before?
I'm guessing this is an infinite loop. That equals must not actually compare them. So I must need to say this. Oh, hold on. Greater than B. This doesn't check to see if it's greater than. If A minus B we need to simulate greater than. Well, is there a greater than?
No. We just had to check for that.
Yeah. Yeah, but we didn't show that in class. I want to make this awesome. A dot subtract B. So if we had 5 and we subtracted 4, 5 is greater than that's what I want to ask.
Before we call it.
Must be looking at that.
Yeah, it is weird. But we're gonna have an awesome solution.
I mean, before we call that, we can check that if the greater than 5 is a gate. If this gets bigger than.
Right, but then you get it as an int. What happens if the values get too big? Yeah, I want to deal with them as big integers because I want this to literally work for arbitrary size numbers.
No, not before here. I mean, before we call that.
Well, yeah, but you would still get from so it would be A dot. Was it int value or something like that?
No, you don't have to check here. Check before you call this method. Or call this method.
All right, but how? How are you going to compare A and B? So it doesn't matter when you do it. I'm just saying, how can you compare A to B?
Okay, because when you put this with like yes.
Yeah. You say you want to check before this line.
Yeah.
But how am I checking? How are you recommending we check? I still have to ask, is new num greater than...
minus, and if it's like less than 0, go with...
Right, but how do I ask, is it less than 0?
Like
New num and new denom are big integers here, just like they are in the other place.
Yes, if new num minus new denom, like... It's not different.
There isn't a difference.
Because there's no difference.
So we have to come up with a... there used to be.
Yeah.
I think it used to be like GT or something. Very interesting. All right, well, we're going to write a helper function here then. How do we ask, is a certain number greater than a certain other number if both of those numbers are big integers? All right, so we are going to write a function in here, private.
Jeez.
Okay, so we're going to write a function here, private static Boolean is greater. This guy's going to take in a big integer a and a big integer b, and it's going to return true if a is a bigger number than b, and false otherwise. Huh? I'm going to convert it to a string. So I'm going to say so once I get it as a string, now I need to compare strings to each other. Make sense? So how do I check to see if I have a string 1, 2, 3 and I have another string 4, 5, 6? How do I ask, is this string greater than this string? Okay, so how about that? Well, can I check the last digits?
And the length, but if it's all zeros, let's say 5 zeros.
Well, no, that's true. If they're all zeros, then we might have a problem. But if one of the strings is longer than the other, if we assume that there's not padded, there's real numbers in there, the longer string is the bigger number. Correct? Yep. So if a dot toString dot length is less than b dot toString dot length. If that's a true statement, then we can just return true. If the length of the first guy is less than the length of the second guy, then it must be a smaller number. Else, if, I'll steal this line. and change the B and the A. If the second number is actually shorter than the first number, then return false. Else, they must be the same length. Correct? If they're the same length, now I need I need to look at them one character at a time, starting with the very first. So, for int I is equal to 0, I is less than a dot toString dot length I plus plus. So we know they're both the same length, so it doesn't matter if I use A or B's length there. It's the same. Okay? And what I want to do is I want to ask the question, if the character I'm currently looking at is larger in A than it is in B, then return true. Correct? Otherwise, move on to the next character. If, now the way I get the current character I'm looking at in A is A dot toString dot char at I. That's how I get an individual character. Correct? How do I get that guy as a number? Okay? Except integer.parseInt takes a string. So I'm going to take, right here, this is, give me the current character I'm looking at, concatenate it onto the empty string, building a string, then parse the integer out of that string. If that string is less than B's, let me minimize this, B's version of that. If that's a true statement, what am I going to do? Return true. Now, if I got through that entire for loop, return false because they must be equivalent, right? Return false. All right, so let me make sure I have all my parentheses right here. Okay, so this guy closes this guy closes that %. This guy closes that guy, this guy closes that guy, this guy closes that guy, so you got one extra. Okay? So now I should have a function that will return true if the first big integer is less than the second big integer. To see if they're all zeros? Yeah. I think we can assume it's not for this example. A negative number could be a problem in this. So we could also say, for our example here, let's just assume we're only dealing with positive numbers. But certainly those are things we should be concerned with. So I'll say if fraction dot is greater, is that what the, yeah, if A is greater than B. AB, if that's a true statement, then do this, else do this. Oh, well, we already got a negative number. Must be because these guys don't, that's not how you compare. So if A dot subtract B dot Doesn't look like equals. Works out here for us. We just compare two, that would do it, but I didn't show you that. So, okay, so I'm going to do this. We subtract those guys from each other, and then we call to string dot char at 0 not equal to the character 0. So if I take my first number, I subtract from it my second number, then I convert that to a string, then I get the character at bucket 0 of that, and I compare that character to a 0. As soon as they are equal to each other, A minus B will be a 0, therefore char at 0 will be a 0 when I compare it to the char 0. So I think this is the equivalent. This is actually kind of a fun problem. System.out.println A. I just want to see what's happening to A and B. I mean, the easy solution is just use GCD, but because we can make this work really easily by just using the big integer GCD. But I'm determined. Okay, so we started off with 5 and 6. Then A became a -1 when I subtracted them. Oh, so it's in an infinite loop. As long as they're not equal to each other, which they're not. So A is 5, B is 6. Then if A is greater than B, which it's not, so we're going to take B and set it equal to B minus A. So B is 1. Right? B is equal to B minus A. So what it actually did is it set A equal to A minus B. That's where we got the -1. So our fraction is greater failed us. This function didn't work. So if the length of A, which should be a 1, is less than the length of B, which it's not in this case, 5 and 6, same length. Else, if the length of B is less than the length of A, which it's not, otherwise we're going to go through A and B, which have the same length, and what we're going to do is we're going to take A at character 0, which should be a 5. Is 5 less than B at bucket 0? It is. So we'll return true. A is in fact less than B. Actually, I know those will work. So what we saw by our output, so 5 is less than B. This is 5. I should have done this one. So we asked, is 5 greater than 6? And we got a true from that. So right off the bat, we got the wrong answer from is greater. So that's our problem was with is greater. So let me print out a length is a dot toString dot length, and b length, our hope is both of these are 1. Ooh. Is it a plus sign maybe? Oh, hold on, it's up here. Okay, so they're both 1. Length is both 1, so that's good. So we know that is fine. So we know that A's length is not less than B's length. We know that B's length is not less than A's length. Therefore, we're going to come into this else. Okay, so we got into the in else. So we're definitely here. So now we're going to walk through A and B. So what I want to do is I want to print out these numbers. Num A is equal to that. Num B is equal to that. We want to get 0 for both of these. So we should get 5 and 6. Num A is 5, num B is 6. Okay? So if 5, oh, haha. So we asked here, is 5, originally we said is 5 less than 6? The answer is yes. So we return true that 5 is greater than 6. So that's not right. So we really want to say is 5 greater than or equal to 6. Is that right? If 5 is greater than or equal to 6, we're going to return true. We necessarily say that it's greater than if it's equal to. No, I think we need to say just greater than. So if 5 is greater than 6, return true. It's not, so we'll spin back through. We'll go to the next one. We don't have one, so we'll return false. That should be correct. Okay, so I think is greater should work now, but let's test is greater before we do anything else. So we're going to go into hello. We'll comment out these couple lines. And we'll do system.out.println fraction dot is greater. Oh, I'm gonna make it private. I did. Let's just make this public for right now, just to test it. So we'll say fraction dot is greater, and we're going to pass it a new big integer 1 and a new big integer 2. Is 1 greater than 2? It is not, so we should get a false. Is 1 greater than 2? Right, now I get it. So this is 1 and 2. The same, is 1 longer than the other one? No, no. So now we have 1 and 2. So, but we're only going to go through this loop one time. So we're at bucket 0, right? So we're going to get integer at parseInt a at bucket 0, which should be a 1. Is 1 greater than a 2? No. So we're not going to return true. But we did return true. A 1 is not greater than a 2. Integer.parseInt, I'm going to take the string version of A and get the character at bucket 0, concatenate that onto the empty string. This should give us the integer, well, that should give us the string 1, and then parsing that should give us the number 1. Is the number 1 greater than the number 2? No. So since that's false, we'll skip past this, go to this 4. So we should be returning a false from here. All right, so here we're gonna do something interesting. I'm gonna show you how to use a debugger. So I just toggled a breakpoint, I think, didn't I? I don't see it in there, but so I'm gonna go to debug here. We can also do it from up here. And I'm going to run this in debug mode. What it's going to do is it's going to stop at the line I set the breakpoint on. Okay? So it should show me the current value of things. Now I have, where's my, here we go. So I'm going to step over some of these lines. So I'll step over here. Where does it give me my values in this guy? Can I just highlight over? Yep, so I is currently 0. So right here I is 0, which means right here I is 0. All right. Can I get what A is? So A is 1. So what I have highlighted there is 1. Is 1 greater than B, which is a 2? So let's step over. Why? The integer version of 1 is not greater than the integer version of 2. feel like I'm on crazy pills.
Feel that one.
Let's see. I'm going to take this number and I'm going to subtract from it this number. Okay, so in our example here, a 1 minus a 2 should give us a negative 1. Correct? All right, so I'm expecting this guy to print out a negative 1.
Is it looking at like?
Am I matching parentheses wrong? That closes that one. This one closes this one, right? So this whole thing is going to boil down to an integer. That integer should be the integer 1. This asks the question, if the integer 1 is greater than this guy, which is integer, so this closes this closes that, so this is the integer 2. If the integer 1 is greater than the integer 2, I may have even referenced that early on in this one of our classes early on. I had a semicolon here at the end of this line. So I was never getting in. This thing was being completely ignored.
Oh.
The return true was just happening. Of course I did that on purpose. Okay, so now it seems to be working a little bit better, a little bit more bestest, most bestest. Okay. It seems to be accurately reducing now. Let's see. Let's do 4/8. Oh, that's correct, right? 1/1. It's really a horrible example. 2/8. This should be 8/16 plus 4/16, so 12/16. So it'd be 6/8, 4/4. So why did this break? Let's see where it crashed. Oh, I got a negative number out of it. All right, so this would be 8/16 plus 4/16. That's 12/16. 6/8, 3/4. It should be 3/4. So now what we need to do is we need to come in here, and we're still breaking on or is greater. It's broken here. Comparing Okay, so that's where we screwed up right there. So we got another negative. So first time we were comparing 12 to 16. Let's go to is greater. Well, actually, we should be able to look at our output. (12 to 16) is 12 greater than 16? No. Is 12 greater than 4? No. Is 12 greater than -8? That's where we failed. So is 12? We kept coming here. So b equals b dot subtract a. So that's 16 is equal to 16 minus 12. So b becomes 4. Great. Is 12 greater than 4? It is. But we didn't treat it as it being greater. 12 has a length of 2. 4 has a length of 1. So we need to go into our greater. If the length of A, I'm backwards here too, jeez. The length of A is greater than the length of B, return true. It's bigger. If the length of B is greater than, man, I tested you guys while we were writing this.
You're the teacher.
All this headache over us, by us I mean me, insisting that we write our own is greater function. We literally wrote all of it backwards. What I wrote was is less than. I meant to write is greater, but I wrote is lesser, is less than, whatever. Okay, so I think this solves the problem. Yeah, it does. This works for this. So now we should be able to create a bunch of random fractions. And we've done random numbers, right? So we'll start this guy off as a new fraction. 1, 2, because we have that long one. And I'm going to create a random. R is equal to new random. For int I is equal to 0. I is less than 1,000. I plus plus. We're going to say sum is equal to sum dot add new fraction r dot, well, I'll cheat a little bit, r dot next long I'll do it this way. We can't do a 0. This will just make my life a lot easier for doing this little example. because we're testing our whole time complexity issue here. So I just want to add up a whole bunch of gigantic. All right, so 1,000 times I'm going to take my starting point, which is the fraction 1/2, and I'm going to keep adding to it a new fraction whose numerator is some random number between 1 and 100,000, and whose denominator is some random number between 1 and a million. Well, we'll start with 100,000. And we'll just keep building that up. In the end, after that loop's done, we'll say sum.display. And the hope is this actually runs fairly quickly, and we're dealing with some really large fractions. Oh, well, this is not going to run quickly, but it actually gives me a good reason to tell you. See how slow this is running? And watch how much quicker it runs here in a second. I think we should be better. We're still in is greater. Where am I printing that? Oh, here we go. Shut up! Everybody relax! Yeah, another negative number? Oh my gosh. What's up? I definitely only got positive numbers, I think, here. That next hint. I added 1 to this to make sure I never had a denominator of 0. So that should be a number between 0 and 100,000. Adding 1 to it should be a number between 1 and 100,000. Let me just display sum each time. Let's see when we went south. Right off the bat. It should have worked. I think r.nextInt should give me a number between 0 and 100,000, that version of it. Just for the sake of argument here, let's just keep adding 1/2 over and over again. Yeah, but that worked. So let's add 1,000 over 2 million. But, Am I just like sucking at hitting the play button? Right. Just for the sake of my own sanity for a second. I'm going to come down here, and for add, we're going to say, instead of this line, we're going to say big integer dot, or gdiv is equal to big integer dot actually it must be new num dot gcd new denom. Let's just use their built-in GCD. Okay. Now let's run it with bigger numbers like I was trying to run it with. Yeah, it runs faster. Yeah, the way we were doing greater must have just been inefficient enough that this was taking too long. So our version of greater was not efficient. So we built in a new time complexity problem into it. So now with this, I think I should be able to do r dot next int. Let's just do 1,000 plus 1, and I'll explain here before we take a break. So now we need one. Plus 1. Okay, good. So clearly, I'll just run it again real quick. We see we got gigantic fraction. I haven't even got to the slash yet. Well, maybe I passed it, but you can see we have a huge fraction there. Much bigger than a int or a long could hold. And it ran pretty quickly. So our ghetto version of greater was lacking greatly, pun intended. You know, there really used to be functions for comparing big integers, less than, greater than. I really thought so.
I thought we did students, but maybe
Because
I didn't.
as I see it, using r is greater. So, just real quick, let me just test something here real quick. It should break on us pretty quickly. But what I'm going to do is I'm going to return a dot int value greater than b dot int value. So I'll just get the integer values of them. But right off the bat there, what we've done is we've limited the value size we could hold inside of a big integer to the size of an int into a single big integer. So now if I scroll down and I go back to my old version of GCD, yeah, I think we're going to break again because it's going to circle back around and give us negative numbers. So the only way to truly do this is write a more efficient version of greater. Comparing big integers yeah, there's got to be like a mathematically sound way of doing it. Where you take one and subtract another. In fact, I'm positive the functions used to be .gt, .lt, less than, greater than. Interesting. Well, in any case, if we had just decided to solve the problem using the built-in GCD function, we could have pulled it off. I think that our version of greater works now. And I think if we allowed the code to sit and run, it would give us the correct answer eventually. but I think we added in our own time complexity issue to it. But in any case, we saw some interesting debugging and things like that there, so it wasn't a total waste. So that was the homework. As you can see, it takes about 15 minutes if you do it the easy way, or 2 hours if you do it in an interesting way. It took us like an hour and 20 minutes, an hour and 15 minutes. Okay, questions about any of that before we take a break, and then we'll come back and start doing some new things? Questions, comments, concerns, bribes? All right, it's 8:15. Why don't we take a 15-minute break, come back at 8:30? Sound good?